The definition of the chain rule. Let f and g be functions for all x in the domain of g for which g is differentiable at x and f is differentiable at g of x. The derivative of the composite function h of x equals f o g of x or f of g of x is given by h prime of x equals f prime of g of x times g prime of x. That is the derivative of the outside function times the derivative of the inside function. In Leibniz notation, if y is a function of u and u is a function of x, then we can write dy dx is equal to dy du times du dx. The chain rule needs to be committed to memory. Example 2.2.5. Find the derivative of f of x equals the quantity x squared plus 3x plus 1 squared using the product rule and also the chain rule. In order to use the product rule, we need to write f of x equals x squared minus 3x plus 1 squared as the product of x squared minus 3x plus 1 times x squared minus 3x plus 1. Then we can apply the product rule. The product rule is the derivative of the first function times the second plus the first function times the derivative of the second. So h prime of x would equal the derivative of x squared minus 3x plus 1 is 2x minus 3. Then we write the second function, which is x squared minus 3x plus 1. Then plus, we'll list the first function, x squared minus 3x plus 1, and take the derivative of the second function, which would be 2x minus 3. Now let's multiply the 2x minus 3 to the x squared minus 3x plus 1. That'll give you 2x cubed minus 6x squared minus 2x, then minus 3x squared plus 9x minus 3. Then we'll plus multiply the next two factors together, which will also give you 2x cubed minus 6x squared plus 2x, then minus 3x squared plus 9x minus 3. Let's combine like terms. And when we do, we see that the derivative h prime of x is 4x cubed minus 18x squared plus 22x minus 6. Now let's use the chain rule to find the derivative of h of x equals the quantity x squared minus 3x plus 1 squared. The chain rule tells us, so we have h prime of x equals, we bring down the power of 2 to the front. So we have 2, and then the inside function, which is x squared minus 3x plus 1, stays the same, and we raise that to the power of 1, because it's 2 minus 1 is 1. And then now take the derivative of the inside function, and the derivative of the inside function is 2x minus 3. Let's go ahead and distribute the 2 through the first set of terms in the parentheses, so we'll have 2x squared minus 2 times negative 3 would be minus 6x plus 2, and still times 2x minus 3. Now, distribute the 2x minus 3 with the 2x squared minus 6x plus 2, which will give you 4x cubed minus 12x squared plus 4x, and then minus 6x squared plus 18x minus 6. We combine like terms and get that the derivative h prime of x is equal to 4x cubed minus 18x squared plus 22x minus 6, just as we got it using the product rule. Example 2.2.6, differentiate the following functions. A, h of x equals the quantity x squared plus 3x plus 1 all raised to the power of 7. If you'll recall, this was the starting exercise for this lesson. Now with the chain rule, we can readily differentiate. That is, we can write h prime of x is equal to, and using the power rule, we have 7 We bring down the 7. 7 minus 1 is 6. Now, the only new thing we do is we keep the inside function in place. So we'll write x squared plus 3x plus 3, and then remember to take the derivative of the inside function, which will be 2x plus 3. We can clean this up a little bit and write this as 7 times 2x plus 3 times x squared plus 3x plus 1 to the power of 6. Let's remember you have to get the order of operations correct, so we can multiply 7 with the quantity 2x plus 3, which will give us 14x plus 21, still in parentheses. Then you got x squared plus 3x plus 1 to the 6th. That is the derivative. Part B, h of x equals the fourth root of the quantity 7x squared minus 1. We'll use our rules of exponents to rewrite this radical as the quantity 7x squared minus 1 raised to the power of 1/4. Now we can readily apply the chain rule. We'll write the derivative h prime of x is equal to, bring down the 1/4, and the power would be 1/4 minus 1, which would give you minus 3/4. The inside function 7x squared minus 1 stays the same. Then we must remember to take the derivative of the inside function. The derivative of 7x squared minus 1 is 14x. Let's clean that up. We'll have 1/4 times 14x times 7x squared minus 1 to the negative 3/4. And we can simplify it a little bit and express this as, let's see, 14/4 would reduce to 7/2, so we can have 7/2 x times 7x squared minus 1 to the negative 3/4. Also, if you wanted to not have the negative exponent, we could write this as, leave the 7x in the numerator, the 2 stays in the denominator. We can write this as the fourth root of the quantity 7x squared minus 1 cubed. Part C, y equals 2x squared minus 1 divided by the quantity 3 times x to the 4th plus 2, and that is squared. You have several options. One of them is the quotient rule, but since we're learning the chain rule, let's use that rule for this problem. To do so, we will rewrite this quotient as a product 2x squared minus 1 times 3x to the 4th plus 2 raised to the power of negative 2. Now we can use the product rule. So let's remember, if y equals the first times the second, then the derivative, y prime, would be the first function's derivative times the second, plus the first function times the second function's derivative. This is going to take a few steps. We won't skip any. So we'll start out with, and I'm going to write d dx as a notation that I need to take the derivative of the first function, which is 2x squared minus 1. And then we are just going to multiply the second function, which would be 3x to the 4th plus 2 raised to the power of negative 2. Plus we'll list the first function, which is 2x squared minus 1. And we'll write d dx to say take the derivative of 3x to the 4th, that's the second function, plus 2 raised to the minus 2. So let's proceed. The derivative of 2x squared minus 1, that will be 4x. We bring down the 2, the derivative of 1 is a constant, so we have 4x times the second function is 3x to the 4th plus 2 raised to the negative 2. Continuing, we will write the first function, 2x squared minus 1, and then we need to take the derivative of 3x to the fourth plus 2 to the negative 2. So we get to use the chain rule here, and the chain rule, we would bring down the negative 2. The inside function, 3x to the fourth plus 2, stays put. The power is negative 2, then subtract 1, so that'll be minus 3. And then we have to take the derivative of the inside function, and the derivative of 3x to the fourth plus 2, we bring down the 4, so 3 times 4 is 12. X to the power of 4 minus 1 is 3, and the derivative of 2 is a constant, is 0. We'll rewrite this, the derivative, without negative exponents, so we'll have y prime equals, for the first one, 4x stays in the numerator, and then we will write 3x to the fourth plus 2 in the denominator with a positive power of 2. Now let's look at the second set of terms. So we have, let's see, a negative, right, minus 2. Let's multiply the negative 2 with the 12x cubed, so I'll have 24x cubed. We have the factor of 2x squared minus 1, and in the denominator, we'll take the 3x to the fourth plus 2, and it was negative 3 in the numerator, so it will be positive 3 in the denominator. Example 2.2.7, differentiate the following functions. A, y equals the natural log of the quantity 9x squared plus 7. Let's recall we had a special property working with logarithms in the previous lessons. That lesson was if we had y equals the natural log of a function, then we had a special property that said the derivative, y prime, is 1 over f of x times f prime of x. That's actually a specific application of the chain rule, so we'll do the same special property under the heading of chain rule for this example. So we'll have y prime equals 1 divided by 9x squared plus 7. And remember, we need to take the derivative of the inside function, so write d dx of 9x squared plus 7. Let's clean it up. Y prime is equal to the derivative of 9x squared. We bring down the 2, so 9 times 2 is 18x. The derivative of 7 is 7's a constant, so that derivative is 0. We need to write the 9x squared plus 7 for the denominator, and we have the derivative. B, f of x equals e to the 5x. We had a special formulation of the chain rule previously, and that rule said if you had y equals e to the power of f of x, then the derivative y prime is equal to e to the f of stays put, e to the f of x, stays put, and we just need to multiply it by the derivative of whatever it was raised to. So let's apply the rule for this example. We'll say f prime of x is equal to, we're going to do e to the 5x, and then we need to multiply it by the derivative of whatever it's raised to. It is raised to 5x, so the derivative would be 5. And we're done. Part C, h of t equals the quantity 2t to the 5th minus 1, all raised to the power of 3. You have several options here. One of them is to multiply this out 3 times. That is, you can write 2t to the 5th minus 1 times 2t to the 5th minus 1 times 2t to the 5th minus 1, and do a whole lot of multiplying algebraically. Or you can combine them and use the product rule a few times. But the chain rule makes finding the derivative of functions like this Rather straightforward. That is, when we take the derivative h prime of t, we bring the power 3 down front. Let's write open parentheses. And as with the power rule, 3 minus 1 is 2. Okay? The inside function stays the same. We must remember to take the derivative of the inside function, and the derivative of the inside function would be, we've got 2t to the 5th minus 1, bring down the 5. So 2 times 5 is 10t, and then 5 minus 1 is 4. The derivative of negative 1, it's a constant, is just 0. So let's clean this up a little bit, and you'll have 3 times 10 t to the 4th times 2t to the 5th minus 1 squared. Let's just multiply the 3 and 10 together, so we have 30t to the 4th times 2t to the 5th minus 1 quantity squared.